So today we're going to start looking at chapter 2. So we're going to do section 2.1. But then tomorrow we skip 2.2. All right, so just make sure if you're looking at what you need to do online because you're out, make sure you check Schoology so you see which lessons we're doing. So we're going to start out on the calculator just by typing that in. Okay, I want to graph it and just kind of see what it looks like. So it says 2x cubed minus 3x squared minus 3x plus 2. Okay, so remember, any questions you have about the calculator, make sure you ask me now. I'll explain anything you want to know. Day of the test, you got to know how to use it and type this stuff in. Okay, so when you type it in, 2x, then you use the up arrow right above the division sign. That's your exponent. Now, if you keep typing, the numbers are going to stay in the exponent. We don't want to stay in the exponent. Once we do 2x cubed, we want to come down from the exponent. So to come down, just press the right arrow, and it'll put you back on the regular line. Minus 3x squared, 3x, and there is a button for squaring on the calculator, so we don't have to use the up arrow to do it. You can press the button that's the fifth one down on the left. When you do minus, I know I've said this, but just make sure, don't use the negative that's below the 3. That's if you want to do a negative number. We're doing subtraction, so use the button on the right. Minus 3x plus 2. Okay, what do I always do before I hit graph? What should we always do? Yep. Yeah, let's do zoom 6. That's going to give us a negative 10 to 10 on the x and the y, and it'll just reset the window. So let's do zoom 6. If that doesn't look good, we'll fix it. That looks fine. That's a good window. Okay, so how many people got a graph that looked something like that? Okay. So a couple things I want to look at. First, I want to look at how many times does that graph cross the x-axis? Yeah, crosses 3 times. Now, if you think about all places where it crosses on the x-axis. What is the y value of any point that is on the x-axis? They all have the same y value. 0. So any point that's on the x-axis has a y value of 0. It hasn't gone up or down at all. Any questions on that? Okay. Now, looking at that graph, it could be kind of hard to figure out the numbers that you could plug in for x and get 0 as the answer. Like, I mean, you could try 2, 2 cubed minus 3, but you can't just keep trying them because if the answer is a decimal, you're probably not going to be able to guess it. So, I want to show you something you can do that makes the answer to that, or makes the roots easy to find. Yeah?
Can you just scroll down a little bit so I can show you?
So I took the problem that we had up above. 2x cubed minus 3x squared minus 3x plus 2. And I did this to it. I wrote it as 3 sets of parentheses. Does anybody remember what you call it when you write something with sets of parentheses like that? You do a lot of that in Algebra 1, where usually you do it with a quadratic. It's one way you can solve a quadratic. When you write it with usually with a quadratic, it's just 2 sets of parentheses. Anyone remember what that's called? Yeah. It's that's how we're going to show that what I have there and what's up there are the same. We're going to distribute that out. But the process of getting this is the opposite of distributing. Does anyone remember what that's called? It begins with an F. What is it? That's the same as distribute. So we are going to FOIL, distribute, whatever you want to call it, to show that this is the same. Yeah? Good, it's factored. So what I've written down here is the factored form of what's up there. Okay, how did I get that? You don't have to worry about how I got this right now. But I want to distribute that out and show that it's exactly the same thing as what I have up there. When you have two sets of parentheses, you distribute the first two. Okay, let's do that first. All right, so we're going to multiply out just like that. Don't worry about the last one right now. All right, so Alex, if I multiply x times 2x, what do I get?
2x squared.
Yep, 2x squared. And then the next one on Kiana is going to be x times negative x, which is how much? If it was x times positive 1, it would be x. But what's x times negative 1? Negative 1 what? Yep, so I'm just going to put negative x. You can also put negative 1x. I'm going to do this off to the side. Austin, what's 1 times 2x?
2x.
So what's negative x combined with positive 2x?
X.
Just x. Okay, so we did the first, outer, inner. Now we do the last. Curtis, what's 1 times negative 1?
Negative 1.
Negative 1. Okay, so that's what you get when you FOIL the first two together. Now, okay, do it one more time. And let's see if we end up with what we had up top. Okay, so this time, first multiply the x times everything. And then multiply the negative 2 times everything. Let's see what we get. Tony, what's x times 2x squared?
2x squared cubed.
Yep, so 2x cubed. I'm just going to come over here because I got more space. 2x cubed. Cameron, what's x times x? X squared. And Sam, what about x times negative 1?
Negative x.
Negative x. Okay, so we're done with that one. Now do it with the negative 2. Fiorella, what's negative 2 times 2x squared?
Negative 4 squared.
Okay, so we got that one. Negative 2 times x is negative 2x. And 1. The last one, what's negative 2 times negative 1? Positive 2. Let's see what we have. So 2x cubed. Okay, so we got that. X squared minus 4x squared. Jenna, what's x squared minus 4x squared?
3x squared.
Positive or negative?
Negative.
Yep, negative. 3x squared. Let's see, we've got negative x and negative 2x. Ryan, what's negative x combined with negative 2x?
Negative 3x.
Negative 3x. And the last one is a plus 2. So when we FOIL it out, that's what we ended up with. Go back up and look at what we started with. 2x cubed minus 3x squared minus 3x plus 2. 2x cubed minus 3x squared minus 3x plus 2. So we just proved that what we wrote in those parentheses is exactly the same thing as what we had up above. So the question is, why do we care about writing it this way compared to writing it the way it is up there? Writing it with the parentheses makes it very easy to do something. makes it very easy to find those. So let's take a look at how we could find the exact values that you could plug in for x, do the math out, and get 0 as the answer. That's what I want to know. But I'm not going to use this. This is too hard to use. We're going to use it the other way we wrote it, with the parentheses. So this is the function I'm calling f of x. And I want to know what can you plug into it to get 0 as an answer. So f of x is x plus 1, 2x minus 1, times x minus 2. That's the formula that I'm working with. And I want to know when does it equal 0. Now, first, does everyone agree what I have written in those parentheses is exactly the same thing as this? Okay, that is the same. Now, you have something times something times something equals 0, the way we've written it with parentheses. You're multiplying 3 things together, and you have to get 0 as the answer. How can that happen? How can you multiply 3 things together and get an answer of 0? What must have to happen? Yep.
You have to multiply it by 0.
Right, you have to multiply by 0 somewhere. You have 3 choices. Here, here, or here. So either x plus 1, either that one must be 0, or 2x minus 1 has to come out to 0, or x minus 2 has to come out to 0. But one of them has to come out to 0 in order for that to work. What would you plug in for x so that x plus 1 gives you 0? Yeah.
-1.
X equals -1. What would you plug in for x here so that 2x minus 1 equals 0? Yep.
1/2.
Yep, 1/2. And what would you plug in for x here? So x minus 2 equals 0. Sky? 2. Now let's go back and look at the picture of this graph. Let's take this. Look at this. And look at the 3 answers that we got. -1, 2, and 1/2. There's -1. There's 2. And there's 1/2, 0.5. So when we write it as sets of parentheses, it makes it super easy to figure out where it crosses the x-axis. So these 3 numbers are called the zeros of the equation. They're also called the roots. Same thing. They're also called the x-intercepts. So any question on not how I would have gotten these 3 sets of parentheses, because we're not going to worry about that when you have a function that has an exponent of 3. If you had a 3 like that, I would give you the sets of parentheses. If all you had was a 2, then I would expect you could figure out the parentheses from that. That's a quadratic. And you would write it with 2 sets of parentheses, not 3. But you need 2. We'll practice that. Any questions on how we got those 3 numbers? Now, when I drew this, what was the highest exponent again in the whole equation? It was a 3. And look at how many times it crosses the x-axis. 3. Yeah.
So you just find whatever numbers make your equation equal to 0?
That's when it asks you to find the roots, yes.
Okay. So if it does that and then like tells you to go look for it and then those spots don't like hit where like your numbers are, does that mean it's like not a function?
So what do you mean?
Okay. So you get 3 numbers up there.
Yeah.
Okay, your -1, your half, and your 2. Your line right there hits each one.
Yeah, it has to.
What if you get one that doesn't? It's not a function.
Then one of these numbers is wrong.
Okay.
Then you did something wrong, but it still could be a function. It still would be a function. But just because it has a highest exponent of a 3, right there, doesn't mean it has to have 3 answers. This one did. It could look something like this. That's the same basic shape as the other one. But how many times does that one cross or touch the x-axis?
Twice.
It only has 2. So it's the same basic shape, but it's been moved up a little bit so that it only crosses twice. Another case you could have, bless you, you could have something like that. That's again the same basic shape, but how many times does that cross? Just once. So there's really 3 different cases you could have. The highest exponent, you can think of this as the most answers it could have. 3 is the most. It can't have more than 3, but it could have less. In this case, it could have 2, or it could have 1. Now, when we talked about a parabola, we saw a parabola could have 0, right? You drew the parabola up there. Do you think a graph that looks like this could ever have 0? No. When the highest exponent is a 3, it will never have 0 because it's going to go down on one side and it's going to go up on the other. If something goes down forever and up forever, it's going to cross this axis at some point. I don't know where, but it is going to cross it. So you can't get 0 in this type of problem. Any questions? What else here? Okay, look at the blue graph again. How many times does the blue graph turn? Twice. So if you look at the highest exponent and you subtract 1 from it, that will tell you how many times the graph could turn. Could turn. Doesn't have to turn. But a formula that has a highest exponent of 3 can turn twice. Just like a formula where the highest exponent is 2, that's a parabola, can turn once. So that highest exponent tells us a lot about what we should be looking for when we draw it. So if I had, let me make up another cubic. It's probably not going to work out nice, but let's try like 8, and let's try like 9, and let's try plus 25. I'm trying to make something that goes off the screen. Okay. So if this problem was in the homework and it said find a complete graph of the function, that is not a good picture of a cubic. There should be some turns in here somewhere. Okay? Or if it doesn't turn, at the least, it should do something like this. It should have a little bend in the middle if it doesn't actually turn. I can't see that in this picture. So how do I, question? So how do I find it? Well, I just have to zoom out on the calculator. What I'm going to do is hit second table, and I want to see, well, how high and low is this graph going? When I'm at -1, my graph is at 11. So it's already a little off the screen. When I'm at -2, my graph is down at almost -70. So it's dropping down pretty quick. When I go to positive 3, my graph is at 150. So negative 10 to 10 is not going to cut it. We need to look higher. And hopefully I can find that turn. Or the bend. The bend could be in the thousands. I don't know where it is because I just made this up. So let's take my window and let's try a y max of 250. Just a guess. It was pretty good. It was way more than I needed. But I found it. I probably could have even gone to like just 100. And that would have been like right around there. That's a good graph of a cubic, because now I can see the bend. So any questions on the idea of what a cubic looks like? Could look the other way too. Instead of going down on the left, it could go down on the right. But that's still a cubic. All right, so in the last problem, what were our answers again? Negative 1, 2, and 1/2. Those three numbers are called the x-intercepts. It's where the graph crosses the x-axis. They're also called the roots of the equation. They're also called the zeros. It's all the same name. Same thing. So a number that you can plug in and get 0 as the answer gives you what is called an x-intercept if you write it as a coordinate. If you write it as just the number, it's called a root or a 0. Now, instead of thinking about a problem where the highest exponent is a 3, let's think about something simpler. I want to think about a straight line. If you draw a straight line that's on a slant, how many times can a line cross the x-axis? Yeah, just once. I said if it was on a slant. It's only going to cross the x-axis once. If it's horizontal, well, that's a special case. It may not cross the x-axis. But I wasn't talking about horizontal. I'm talking about on a slant. So here's something that we can write down that represents a linear equation. It's kind of like y equals mx plus b. I just use the same letter as the book, ax plus b. This would represent a linear equation. Look at the x. There's no exponent on it. If you don't put an exponent, what exponent is always there? Yep, 1. You don't have to write the 1, but it is a 1. When the highest exponent is a 1, that's called a linear equation. Means when you draw it, it's a straight line. Can anyone tell me here, how would you get the x by itself? Again, you probably have a number for the a and the b, but I just want to know, what would you do with the b, and then what would you do with the a? Yep.
Subtract the b and then divide the a.
Exactly. Minus the b, and then divide by the a. That's how you get the answer to that problem. Minus the b and divide by the a. That's the simplest really equation that we're going to work with that we have to set equal to 0. From there, they get harder. Okay, we look at quadratics, and then we looked at a cubic. That's the very first one we did. All right, so let's apply that idea to this problem. You subtract the b and divide by the a.
At this time, all seniors with your.
So 2x plus 3 equals 0. So pretty much doing exactly what Dustin said. Can someone tell me the 2 steps to get x by itself? Sky?
Minus the 3.
Yep.
2x equals negative 3, then divide by 2.
So when you minus the 3, you get 2x equals negative 3, and then you said
You divide by 2.
divide by the 2. And there's my answer. X equals negative 3 over 2. That's the number that you could plug in for x, and it would come out to 0. Can someone remind me, what do we call that number? Couple different things? Yeah? So it's an improper fraction, but what do we call it because it's the number we can plug in that makes this equal to 0? Yep? Yep, if you write it as a coordinate, it's called the x-intercept. And what else is it called if we write it as just a number? Yeah? A root or? A 0. Yep. This is called the root of the equation or the 0 of the equation. Any questions on that? Okay. Let's look at this one. All right. So let's take the exponent up one number. We're going to look at what happens when the exponent is a 2. We kind of already looked at this yesterday for the most part. When you draw out something that's a quadratic equation, does anyone remember what the name of that thing is called, the shape you get? Yeah?
Parabola.
It's a parabola. And how many times can a parabola cross the x-axis? Yep. Twice is one possibility. Yeah. Once. Or none. Yeah. So the 3 cases you can get twice, once, none. So remember from yesterday how we can use the discriminant, that's what this thing is called, the b squared minus 4ac, to figure that out. If b squared minus 4ac comes out positive, how many times does it cross? Yep. Twice. What if b squared minus 4ac comes out negative? How many times? Yeah? 0, none. If it comes out negative, it doesn't cross at all. And then if this comes out to exactly 0, it means it crosses the axis 1 time. So the discriminant can quickly tell you which one of these 3 cases you have. Okay, so when the highest exponent is a 2, that's an equation we can work with. When it's a 3, like the first problem we did, that's a little harder. But when it's a 2, we can work with that. We have the quadratic formula we can use to solve it, or we can try and factor. If the problem says to you that they want an exact answer, there's only one way to get an exact answer. You have to either factor it or use quadratic formula. You have to use algebra. But if the problem says they want an approximate answer, that opens it up to being able to use something else. What else do you think I can use to help me solve this if they say they only want an answer that's approximate? I'm not going to have to do algebra. So what else could we use? So algebra is one approach we take to solving all kinds of things in here, but I've been teaching you another way we can do everything. It might be new for a lot of you this year. What is that?
Calculator.
The calculator, right? The graphing calculator. So, graphing calculator is fine if the answer only has to be approximate. What the graphing calculator won't do is give you an exact answer. Only the quadratic formula can do that. So let's solve this approximately using the graphing calculator. First of all, we want to get it set up. when we want to solve a quadratic, what number do we always get it equal to?
0.
We always get it equal to 0. So let's move everything to the left. Cameron, could you tell me, how would I move the 1 to the other side?
Subtract 1 and add 2x.
And how would I get the negative 2x on the other side?
Add 2x.
Add the 2x. So I had everything written vertically here. I'm just going to write it horizontally. That negative 1 plus 1 is gone. Negative 2x plus 2x is gone. So what's on the right-hand side now? 0. That's exactly what we wanted. And on the left, 2x squared. Put the plus 2x next, and the minus 1. Now, this is A, this is B, and this is C. If we were going to use quadratic formula, that's what I would make sure I know. What's A, what's B, and what's C. But we're not. We're going to graph. All right, so let's type that in. If you have anything in there, you can just clear it out. We're going to put in 2x squared plus 2x minus 1. Okay, so when you type it in, it should look just like that. Okay, I'm not ready to see it on the screen yet. What do I always want to make sure I do first? Zoom 6. We always do zoom 6. I'm not saying zoom 6 is always going to be a good window. We might have to fix it. But that one happens to be fine. So the quick question I can answer is, how many times does it cross the x-axis?
2 times.
2 times. Okay, so that I know. But they want to know not just how many times, they want me to solve it. That means they want to know where it crosses. Approximately. So we're going to get 2 answers. Call them x1 and x2. Where it crosses is called the x-intercept. But what was another name for it besides the x-intercept? Yep. The roots, and another name? The zeros. If you press second calc, there is an option there that will calculate what we want. Which option do you think it is? Which option? Yeah?
2.
Yeah, option 2. It's going to calculate a 0. Now, the way you have to do it is you have to pick that option, and then you're going to have to hit enter 3 times. And I'll show you where you have to hit enter. All right, so second calc, 0. The first question that it asks me is left bound. That means you need to move the cursor somewhere to the left of where you want to find the 0. The calculator can only do 1 at a time. So we're going to have to do this twice. So left bound, start by moving your cursor to the left of one of your zeros and hit enter. What it does is put a dotted line, and that tells the calculator to look for where it crosses the axis between that dotted line. And now we're going to give it another one, right bound. So pick a point that's a little bit to the right of one of your zeros. And then hit enter. Now you should have something like this. 2 dotted lines, and the calculator is going to look between them. The guess doesn't really matter. You can move the guess close to where you think it is, but in this case it doesn't really matter. Hit enter, and it tells me that's one of the answers. You should have gotten a 0 at negative 1.37. All right. So if you're not sure how we did it, we're going to do it again. So can somebody walk me through how I would find the other 0? What do I have to do? Yep.
You hit second calc,
Okay.
and then 2.
Got it. left, a little bit left of that second 0. Okay, I went a little bit left.
Enter.
Then I gotta hit enter, that's important.
And then right on. And then 0.
Okay, go to the right of it, yeah.
And then enter.
Then enter again.
Use enter.
I can just hit enter again. And then it gives me the second answer. So those are my two answers. 0.37 and negative 1.37. And it was okay to do it that way because the directions said approximate. It did not have to be exact.
I'm getting an error.
You're getting an error?
Yeah.
Did you get the graph to show up?
Yeah, I got the graph to show, but then when I do the like the second and then I do 0, and I do the left bound, the right bound, it'll say error.
So second calc, let's just do it again. Second calc, 0. So your left bound should be like somewhere right around there. Is that where you put it?
No.
Yeah, it needs to be right about there. Because then when I hit enter, it's going to put a dotted line right here. What I'm trying to do is go to the left of this point a little bit and to the right of that point. Did it work that time?
Yeah.
Okay. Did anyone have any other question on that? So that would be something like on a test. You have to know how to calculate a 0. If you say, oh, I don't remember what button to press, well, that's part of what I'm seeing if you remember if I taught you that. Okay. Any questions on that? All right. So what we just did there was an example of finding a root graphically. So finding roots graphically. The old way you have to find a root graphically is basically to do something like this. You had to press trace and move it, move it till you think you got it pretty close. Right there. And then what you'd have to do is zoom in on that spot. You'd have to press zoom, 2, and zoom in to now see it closer. Right? And then what you'd do is you'd press trace again. And now I would move it a little closer. So now it looks like I'm getting a little bit better answer because I'm even closer. And then I would have to zoom in again. And I would have to keep zooming in until I could get as good of an answer as I thought I needed. So I press trace. All right, so now I'm even closer. And then I'd zoom in again. And I'd do this maybe 6 or 7 times until I finally zoomed in enough and got a pretty accurate answer. But now, because we have the second calc root, that's the best way for finding roots. So we don't have to do that zooming thing because it takes a while. Because you got to do that zooming thing for every root. So if you had 3 of them, you're going to be zooming in 3 times. You probably have to zoom in 6 or 7 times per root to get a good answer. But this is the best way for finding roots graphically. On some older calculators, it might actually be called root when you press second calc. On my calculators, it is called 0. So here's another one that says solve approximately. But it's different than the last one. The last one, what was the highest exponent in the last problem? Yeah?
Second.
Yeah, it was to the second power. So if I wanted to on the last one, I could do the quadratic formula and get the answer. What's the highest exponent on this one? Yeah? It's a 3. So the quadratic formula would not work on a problem like this. There is a formula that does work. It's called the cubic formula, but it's not a formula that you've ever learned or ever will learn, most likely in high school. So it's not one that we could easily do with algebra even if you wanted to, right? At least with a formula. So let's take a look and see how we can solve it. There is something we have to do manually, and it's the same thing we do with a quadratic. What number do we always want to get on this side? 0. If this was already a 0, then yes, you could solve it with algebra, because something special would happen here. But it's not. It's a 1. And we're not worried about using algebra anyway. So how about Abigail? How would I get this equal to 0? And what would you subtract from both sides?
Oh,
The 1. Yeah, so we're just going to minus the 1. That's gone. So now we have 0. We've got x cubed plus 2x minus 1 equals 0. Since it's equal to 0, we are solving for the roots. How many times can a cubic, this is the first one we did, how many times can a cubic cross the x-axis at most? Dustin? 3. Could it cross twice? Yeah, that's an option. Can you get once? That's an option. Can you get 0? No, can't get 0. So let's draw this out. And with the cubic, remember, we're looking for where either we see that turn in the middle, or we at least see a bend. Okay, we have to see one of those two things. So we've got x cubed plus 2x minus 1. Now, my window is all messed up from the zooming I did on the last problem. So I'm going to just do zoom 6, reset the whole thing. And I want to see if I see a bend or I see a turn. In this case, I see a bend. And that's it. That's all you're going to see. No matter how much more you zoom out, this is just going to keep going like that. That's just going to keep going like that. So how many times does this one cross? Well,
2.
okay. Where are the, can you kind of point out to me where the 2 spots are? I'll just move this over here and make it bigger.
Where it's hitting the y and the x-axis.
Okay, we're only interested in where it crosses the x.
Oh, okay.
So how many times does it cross?
Once.
Yeah, it only crosses it once. And we're going to find it just like we found in the last problem. So second, calc 0. Make sure you're to the left, to the right, and then we're going to hit enter on the guess. Now it looks like to me it's about 0.5, somewhere between 0 and 1, I think. Can someone tell me what you get for an answer when you do it? Yeah.
0.45.
Let's see. Yep, I agree. 0.45. There's your root. So this isn't a problem where you'd be able to guess the answer. Right? You're not going to guess that the answer is 0.45. So you've got to know how to do it on the calculator. Any questions on that one? All right. So, last thing, which we already talked a little bit about this when we started, but equations where the highest exponent is a 3. Yes, Dustin. So if the highest exponent is a 3, this is the most complicated that it could look. The A, the B, the C, and the D would all be numbers. And depending on what those numbers are, it's going to control how much of a bend you get in the middle of it, or how much of a turn. I've already shown you all the different types you can get. It always goes up on one side, and it goes down on the other. Sometimes you have two turns in the middle. Sometimes you only get something that tries to turn, but it never really does, and it just bends. But that's the basic shape of all third-degree polynomials. They look like one of those four. I mean, the turn can be a little bit more gradual, but that and that are basically the same thing. Same type. Any questions on the four different types? Okay. So in the next problem we're going to do, it's asking how many solutions does the equation have? Make sure you read what the question's asking. At this point, it's not asking you what the answer is. It's asking you how many answers there are. Okay? And there's our equation. X cubed minus 5x squared plus 6x minus 1. Jackson, first of all, can you tell me what type of equation is that again? It's not a quadratic, because that would be if the highest exponent was 2. What do we call it when the highest exponent is a 3? Remember, yeah? So polynomial is the general term for all of them. This is a specific type of polynomial. So degree 1 is linear, degree 2 is quadratic. Third degree, or there is a word for it. Yeah?
Is it trinomial?
Trinomial has to do with how many things you have. We have 4 things here. That's a little different. Trinomial would be something like this. Like if you got rid of this. 1, 2, 3 things. But we're not interested in how many things. I'm looking for the name because of the highest exponent. Yeah? Cubic. Very good. This is a cubic polynomial, also called third degree. In general, when you get above 3, there's no special name that's used a lot. You just say degree 4, degree 5. All right, so how many solutions does this have? How am I going to figure that out? Yep. Yep. Okay, so I'm going to use my graphing calculator. What do I do? Okay, so we're going to go to y equals. Okay, actually clear the old one first, and then you said type in what?
X cubed.
X cubed, got it.
Minus 5 squared.
Yep, 5x squared.
Plus 6x.
Plus 6x minus 1. Type that whole thing in. Okay. How about Austin, what do I do next?
You go to the other side.
Go to where? Go to the other side?
Yes.
What do you mean? This is the whole thing.
Alright.
There's nothing else like hidden under the calculator.
You have to distribute it.
So the only time you do distributive properties is if you see parentheses. Since there's no parentheses in here, there's nothing. It's not like the first one we did where you had 3 sets of parentheses and we had to distribute. So this one we're using the calculator. So the next step is a step on the calculator.
Okay. Do we have to put where the exponents into the calculator?
We've already done that. That whole thing with the exponents is already typed in.
I do not know.
So what do we do now that it's all typed in? Caleb? I'm sorry, Alex?
You gotta zoom 6 or graph.
Yeah, zoom 6, because we want to check and make sure we get that standard window back. So zoom 6. And I'd say that's a good window for this problem. There's nothing we need to adjust. And that should answer our question. How many solutions does that equation have? Well, Chris. How many? Three. And what do you call those three things? Like these three spots where it crosses the axis?
The roots or the zeros?
The roots or the zeros or the x-intercepts. Yep. So the answer here is there are three of them. Now, the last question says, find the one in the middle. So when they mean the one in the middle, they mean the one in the middle. They mean this one. Not the one that's on the left or the right, but the root that's right in the middle. All right, so Fiorella, how do I find the root that's in the middle?
Second count.
Yep.
And 2.
2, got it.
Go over to the farther right. A little bit.
Yep, we'll go a little further to the right. So the goal is we want to isolate one of those roots between dotted lines. We don't want to have more than one. So that's good.
And to the further right, sorry.
We'll go a little further to the right. That's good there. Okay.
And go to make a guess where it would intersect.
So we can put our guess close to where we think it crosses. So I got that.
And then enter.
And then here, enter. And we should get an answer of 1.55. 1.5.
I got 1.98.
You got 1.98.
I don't know.
I think he did the ones to the left.
So it looks like there's one at like 0.1 maybe. This one was the one we just did. And this one looks like it's at like 3 point something. So the first thing is, did your picture look exactly like that?
Yeah. It's just when I go and do the zero things, I just don't get the numbers that you guys get.
So we have enough time. I can come take a look at it if you guys don't figure it out. Because that's the last one. But let's see if it comes out. Yeah?
I was just wondering if you could go over the steps in the calculator after you hit second and count.
Did you? Yes, Dustin, did you get it?
Yeah.
Okay, so let's do one more then. Let's do the one that's on the right. Okay, so to get the one that was on the right, you press second, calc, 0. And now we have to hit enter 3 times in different spots. Pick a point that you know is definitely to the left of where it crosses the x-axis and hit enter. Okay, I'm going for this one. So I have a dotted line to the left of it. I kind of want to get a dotted line maybe right about there to the right of it. So now I'm going to go to the right. I'm going to hit enter. And that's good. So at this step, you should see 2 dotted lines, and you should see it crossing the x-axis once between them. Okay, so far? Okay. So now the last thing is it's asking me for a guess. The guess isn't really important for this thing. I'm not saying it's not important ever. It is important sometimes, but not for this. Move the guess close, if you want. Hit enter. And the answer that's on the right is 3.25. It should say 3.25. Did you get 3.25?
No.
No? But you were with me right up until that step?
Yeah. Can you just redo the last one?
The last step?
Yeah.
So, second, count.
It says phrase. It doesn't say count.
So you press second, the blue button, or maybe it's a different color on yours. Second, and then the button, I can't make that bigger. But it says calc right above trace. Okay. So second calc, 2, Pick a point to the left. Pick a point to the right. That one's okay. It's a little skinnier, but it's fine. I've got my 2 dotted lines. And at this point, just hit enter. You don't really have to do anything. If you put the dotted lines in the right spot, it should automatically give you the answer. 3.25. Okay, you got it? Okay, good. Any other questions on calculating the roots? Okay, so the answer here was the one in the middle, which was 1.55. All right. So that's section 2.1. Okay, so that's the homework for tonight on page 82. It might also go on to page 83. So we'll look at that first thing tomorrow, go over it, and then we'll go to section 2.3, and we're going to finish the week up with, I think it's 2.4. A reminder, we do have a half day on Friday, so I'm leaning towards doing something as like a take-home on Thursday instead of the homework. If that's a concern, if you think, you know what, I can't do it Thursday night because I have to work and I don't get home until 2 in the morning, there's no way I'm going to get it done, then you can talk to me and we'll have to figure out something different. Okay, but we'll talk about that tomorrow.
Oh, well, the catch is tied.